Exercise 42, page 86, question number 7. This is the one maybe worth looking at because actually it's an example of something that's what's called a perfect square, which is something that the next section talks about in the textbook, something that's not covered at the BTEC level, but the foundation degree level we'll be talking about these perfect square ideas. The way to identify that this is a perfect square is to look at the coefficient of x, the number in front of x, which is -4. If I half that to get -2 and then square it, -2 squared gives 4, which is this number here. If that's the case, this is what's called a perfect square. So if you look at a quadratic equation, take the coefficient of x, which in this case is -4, half it, and then square it, and that turns out to be this number, then you've got a perfect square. So instantly I would have known that was a perfect square, but we can solve it anyway without knowing that that's a perfect square, but it helps if we do, as we'll see. So if I now take two brackets, factorize it, as usual. Now I think of two numbers that multiply together to give 4 and add together to give -4. Two numbers that multiply together give 4 are 4 and 1, or 2 and 2. I want positive 4, so it's going to be either both positive or both negative. Well, I want -4 when I add them, so the only combination is the second one, -2 minus 2 gives -4. So this is going to be -2 minus 2. Same number. So in other words, what we have here is that x minus 2 squared equals 0. Or we can think of x minus 2 times x minus 2 equals 0. Well, looking at this, we can see that either that bracket, the first bracket, or the second bracket is 0, but they're both the same bracket. So x minus 2 equals 0 is the equation we need to solve. So x equals 2. There's only one solution for a perfect square like this. And you might be able to see actually that this -2 comes from half of the coefficient of x, which is why I half it. So I know that this number here, this -2 in here, comes from half of whatever this is, -4. And that always works. So if I half this coefficient of x, this -4, and square it and get this number 4, then I know that it factorizes and that the number that goes in the bracket is half the coefficient of x, which is -2, which means that x equals 2. So instantly I can solve it. How come only one solution? Well, if we plot the function y equals x squared minus 4x plus 4, or y equals x minus 2 squared, and look for where y equals 0, we can see this is a special case where the curve just touches the x-axis at one point where x equals 2. So this is a special case where there's only one solution, and that's an example of a perfect square. And if you look at the next section in the textbook that follows this exercise, you'll see how you can use the idea of completing squares, uses the perfect square to solve quadratic equations.